Have you ever considered how crucial the choice of an optimal structural system is for your architectural project? A structural system, the backbone of any architectural piece, is integral to the success of your design. It's not just about beams and columns. It's about understanding the interplay of various factors like load resistance, building function, integration with other systems, and even social or cultural influences. It's about making informed decisions that positively impact your design. Today we will explore the process of selecting the optimal structural system for your architectural projects. First, let's delve into the concept of resistance to loads. In architecture, loads refer to the forces that a structure must bear. There are two main types of loads: dead loads and live loads. Dead loads are the permanent fixed weights that a structure carries, like the weight of the building materials themselves. On the other hand, live loads are temporary or changing pressures, such as people moving around, furniture, or even snow on the roof. When selecting a structural system, both these loads play a crucial role. For instance, a building designed to house an extensive library, carrying a significant dead load of books, may require a different structural system than a sports arena, which must accommodate fluctuating live loads of cheering crowds. Every structure has to withstand a unique combination of dead and live loads. Understanding the loads that your structure will withstand helps determine the most suitable structural system. The function of the building also plays a significant role in the selection process. Picture this: a warehouse will require a different structural system than a high-rise apartment building. The warehouse may need large, open floor plans and high ceilings to accommodate storage, while the apartment building requires a system that can support multiple floors and resist different types of loads. Similarly, the structural system of a hospital building, which needs to accommodate heavy medical equipment and ensure patient safety, will be different from that of a concert hall, where acoustics and audience sightlines are key considerations. Let's not forget about future use and adaptability. With the rapid pace of change in our world, a building's function may evolve over time. Selecting a flexible structural system can allow for easier renovations and modifications down the line. Remember, the building's use and function should always align with the chosen structural system. Integration with other building systems is another vital factor. When selecting the optimal structural system for your architectural project, it's essential to consider how this system will work in tandem with other building systems. These could include mechanical, electrical, and plumbing systems. Imagine the structural system as the skeleton of the building, providing the main support. However, this skeleton must accommodate the veins and arteries, which are the mechanical, electrical, and plumbing systems. The chosen structural system should allow for easy installation and maintenance of these systems. It should also permit modifications and upgrades in the future without major disruptions. Think of it as a symphony, where each instrument plays a crucial part. When they all work together, the result is a harmonious and functional masterpiece. Similarly, the structural system should seamlessly integrate with other systems, creating a coherent, efficient, and cost-effective design. Choosing a system that integrates well with other building systems ensures a harmonious and functional design. There are other factors too that influence the selection of structural systems. Let's dive into the myriad of factors that can sway the choice of a structural system. At the forefront is cost. It's an undeniable reality that budget constraints can often dictate the selection of a structural system. Lower cost systems may be appealing, but remember that initial cost savings could lead to higher maintenance or operational costs in the long run. Fire resistance is another crucial factor. Different structural systems have varying degrees of fire resistance. Concrete, for instance, is more fire resistant than wood. The choice of a structural system should therefore consider the building's vulnerability to fire and the potential consequences of a fire incident. Construction limitations, too, can influence the choice of a structural system. The project's location, availability of materials, and the local workforce's skills can all impact what structural systems are feasible. For example, in a location where wood is readily available and the workforce is skilled in timber construction, a wood structural system might be the most practical choice. Style, though often overlooked, plays a significant role. The structural system can greatly influence the aesthetic of a building. A steel frame, for example, can lend a modern industrial look to a building, while a timber frame might evoke a more traditional rustic aesthetic. The structural system should be in harmony with the desired style and aesthetic of the building. Lastly, social and cultural influences can affect the selection of a structural system. In some cultures, certain materials might have symbolic or historical significance, influencing the choice of structural system. For example, in Japan, Wood has been traditionally used in construction due to its symbolic connection to nature and longevity. So, whether it's cost, fire resistance, construction limitations, style, or social and cultural influences, each of these factors can have a significant impact on the choice of a structural system. They must all be thoroughly considered and weighed against each other to make an informed decision. All these factors collectively influence the selection of the best structural system for your project. Let's quickly recap what we've learned. We've delved into the crucial aspect of resistance to loads, understanding the significance of both dead and live loads. Remember, dead loads are the immovable, permanent elements of a structure, while live loads are temporary and can vary. The right structural system should efficiently bear both types of loads. Then, we explored the importance of building use and function. Each building serves a purpose, perhaps a residential home, an office complex, or a museum. The structural system should not only accommodate the intended function but also enhance it. We also discussed the integration of your chosen structural system with other building systems. This is about achieving harmony and coherence in the design. The structural system should work seamlessly with the electrical, plumbing, and HVAC systems, among others. And finally, we touched on other influences that can affect your choice. These may include cost implications, fire resistance, construction limitations, style, and social and cultural factors. Every project has its unique constraints and opportunities, and the optimal structural system should address these effectively. Remember, selecting the optimal structural system is a critical step in your architectural project. It requires careful consideration of various factors to achieve a design that is both aesthetically pleasing and structurally sound.